Let's have a look at Universal Serial Bus or USB. Universal Serial Bus or USB was released in 1996. Since then, it has become a very popular standard. One of the reasons it has become popular is that it supports hot swapping. This means that any USB device can be plugged in or unplugged at any time. USB has been used for a lot of devices. Storage devices have become very popular, and there have been a lot of different USB devices, including the practical and the unusual. It's pretty clear at this stage that USB is here to stay for the foreseeable future. To better understand how USB works, I'll start with the very first version and then work my way up to the latest version. The first version of USB that I will look at is USB 1.1, which was released in 1998. There was another version before this, but version 1.1 was the first version to take off. Since the previous version never did, you can pretend it does not exist, thus making USB 1.1 the first used version as far as we're concerned. There were 4 connection types introduced. The Type A connection goes into the computer and the Type B into the device. These came in a larger and smaller version. The smaller version is called Mini. The smaller connection is usually used for things like mobile devices and cameras. Electrically, all the connections are the same. USB 1.1 is still used today, so we can't really say it's obsolete. However, for reasons that I will cover later in the video, we don't really need to know a lot about it. Essentially, just know it exists and know the connections, which should not be a problem since the next version of USB uses the same connections. To get an understanding of where we may come across USB 1.1, I will have a look at the USB devices on a computer using USB device viewing software. On this computer, there is one USB 1.1 device. In this case, it's at the bottom of the list, so I will reverse the list. This device is the cheapest keyboard I could find. Most USB devices on the market nowadays will support a higher USB version, but you'll find some still using USB 1.1. In the case of a keyboard, it's a low-speed device, as you don't need much speed. USB 1.1 is not fast by today's standards, but it's fast enough for a keyboard. You'll notice that the device appears 3 times. USB supports multiple data channels to the device which are referred to as pipes. In the case of this keyboard, the keyboard uses 3 pipes to transfer data and send control information to the computer. Notice that the USB has detected the keyboard using USB version 1.1. As I said before, there's not too much that you need to know about USB 1.1 other than it exists and is still used for a small number of devices. Let's have a look at why we don't need to worry too much about it. In the year 2000, USB 2 was released. USB 2 uses the same connectors and cables as USB 1.1. USB 2 is backward compatible with USB 1.1. It achieves this compatibility by simply reducing the speed if a USB 1.1 device is used. You can see why we're not really concerned with USB 1.1 nowadays. Since USB 2 was released so long ago, all modern computers and devices support it. This includes devices such as USB hubs. As mentioned, USB 1.1 is still used for some devices like keyboards which don't require a lot of speed. To use USB 1.1 devices, you can simply plug it into a USB 2 port and it will automatically slow down to USB 1.1 speed. Simple, easy, and nothing to even worry about. The USB 2 standard also adds 2 additional connectors. These are the micro connectors. As before, you have the Type A connector which is designed to be plugged into a device like a computer, and the Type B connector that is designed to plug into your device. Most computers don't use the micro A connection but rather the standard Type A connection. Although I have not covered it yet, USB uses a host-device relationship. Traditionally, the Type A connections, including Mini A connection and Micro A connection, are designed to plug into a device like a computer. Thus, they are the host side. The Type B connection, including Mini B connection and Micro B connection, were designed to plug into the device itself. This created a host-device relationship which works well, but there's a problem in this design with some modern devices. Let's have a look at why. To understand what the limitations of a host and device design are, let's consider an example. In this case, I'm plugging a phone into a computer using a USB cable. This will allow me to access files on the phone using the computer. Thus, the phone is acting as a device. The limitations occur when we want the phone to instead act as a host rather than a device. An example of this is when we plug a USB flash drive directly into the phone. When we do this, the phone now needs to act as the host. For the sake of making this example simple, I've used a Type-C connector which I will cover later in this video. The principle is the same regardless of which connector you use. If your phone does not support a particular connection, you can always purchase an adapter. The technology that allows this to occur is called USB to go. We learned previously that the Type-A connector goes to the host and the Type-B connector goes to the device. Thus, the existing connectors don't allow a device to be a host or a device. To get around this, two additional connectors are added. These connectors can be used as a Type-A or Type-B connector. Essentially, these connectors are a combination of the A and B type connectors in one. Thus, they can be used with both. Now that we understand how the host-device relationship works in USB, let's now have a closer look at how the host itself works. A host device, such as your computer, will have a host controller. This may be a separate chip or be part of another chip on the motherboard. This forms the root of all USB communication. All USB communication gets sent to the host controller. On some computers, you may have multiple host controllers. If this is the case on your computer, you may find that you get different results when you connect USB devices to different USB ports on the computer. Basically, this is because different USB ports on the computer may be connected to different USB controllers. For the moment, I'll only be discussing USB 2. Later in the video, I will talk about how USB 3 changes things. The host controller has one root hub. This means the host controller transfers data in and out of the chip. The host controller is connected to the root hub, which is responsible for transferring data to any of the USB devices connected to it. Each root hub can support 127 devices using a hub and spoke design. However, there are some rules about how we connect devices to the root hub. Let's have a look. The root hub will have a number of connections. In this example, the root hub has 10. In most, but not all cases, the USB connections on your computer will connect directly to the root hub. Later in the video, I will look at some cases where it does not. This becomes important if you're using high-speed devices because you want a direct connection, but for slow-speed devices, you won't need to worry about it. For the moment, I will assume the USB port we are using connects directly to the root hub. When you plug in a device like a USB flash drive, this makes a direct connection to the root hub. USB uses a hub and spoke design. To understand how it works, let's consider that we plug a USB hub into the computer. A USB hub allows a single port to be split into multiple ports. In this example, 4 ports are available. Thus, when working with USB, hub and spoke refers to a single uplink port and up to 4 download ports. USB provides power for the device. To support USB, you don't need to know much about power. Just know how to resolve USB problems if you don't have enough power. Don't be too concerned about the numbers. Just understand how to resolve power problems if and when you experience them. For USB 2, the upstream port is required to provide at least 100 mA for a maximum of 500 mA of power if it can. All the downstream ports are required to provide the same, that is, a minimum of 100 mA to a maximum of 500 mA if possible. The amount of current that could be drawn was increased. The key point to take away here is, if the port can provide more power, it can do so up to 500 mA. If it can't, it always needs to be able to provide the minimum of 100 mA. If this is confusing, it will make more sense later in the video. If we have 4 devices plugged into the hub, each device is essentially guaranteed to have a minimum of 100 mA if it needs it. Thus, each port is required to provide the minimum of 100 mA of power. The question here is, if we have 500 mA and need a minimum of 400 to be allocated to the 4 ports if they requested it, what happens with the last 100 mA? The answer is, this last 100 mA is used to power the USB hub. Thus, a USB hub has a maximum of 4 USB ports. If the USB hub has more than 4, it can't provide the minimum of 100 mA to each port and thus is considered not to meet the USB specification. There are some USB hubs on the market that don't follow the standard, which can be problematic. There are also some USB hubs on the market that use daisy chaining to provide more ports. I'll cover that in more detail later in the video. If you connect devices to the hub that draw a lot of power, the hub might not have enough power for all of them. Let's see how you can solve this problem. If you're having power problems, use a USB-powered hub. You can see an example of a powered USB hub. All 4 output ports have a USB flash drive attached. To connect the USB hub to a computer, a USB cable is used. Next, an external power supply needs to be connected. When you purchase a USB hub, if the hub does not come with a power supply, it may still support an external power supply. In this case, you need to purchase a suitable one to use with the USB hub. The external power supply provides the maximum power to all the outgoing ports, hopefully. I say hopefully because you may find that cheap or poorly made hubs or power supplies may not deliver enough power. Having some external power is better than having none, but if you have one of these and attach too many USB devices that require a lot of power, you may find that some of them fail due to not having enough power. I will have a closer look at how to troubleshoot power problems, but before I do that, I will first have a look at a USB tool that allows us to get a better understanding of what is happening with our USB devices. For the CompTIA exam, you won't need to know anything about USB view. I'm only demonstrating it here so we can get a deeper understanding of what's happening with USB in our computer. To install it, you need to install Windows SDK. When installing Windows SDK, you need to make sure that the option Debugging Tools for Windows is ticked. None of the other options needs to be ticked. Once Windows SDK is installed, go to the Debugging folder. Next, go to the folder for your architecture. In the case of my computer, it'll be x64. Once in this folder, run the program USB View. USB View allows you to see the controllers, the root hub, the ports, and any other USB hub or devices connected. In the case of this computer, there's one USB controller in the computer. Some computers will have multiple USB controllers, usually one with a lot of connectors on it and another with only a few. Usually, if it does not have many connectors, they will be the faster ones. Regardless of how many controllers you have, each controller will have one root hub. The root hub will have all the connections listed under it. I will now plug in my USB hub with the 4 USB flash drives in it. It will take a few seconds for the computer to register the USB hub and the 4 flash drives in it. You will notice the USB hub has been detected with the 4 USB flash drives under it. Notice that one of the USB flash drives has come up as reset. Essentially, something has gone wrong and the USB hub is attempting to reset the connection. However, it has become stuck. To fix this, I will simply unplug the USB flash drive and plug it in again. After a few seconds, the flash drive will be detected and become accessible. If you're having unusual problems, USB View may help you determine what the problem may be. I will next have a look at how power works in USB. In this demonstration, I will be using 2 USB power testers to measure the current used by USB. USB testers are a good device that you can use to test your USB ports to ensure they are working. You won't get a question on this in the exam, but I think having a little context about how things work will help you in troubleshooting. In this setup, I have a mobile phone charger that is connected to one of the USB testers. The USB tester is connected to a USB hub. The USB hub will also have an external USB hard disk connected, which is not currently connected. Both devices require a lot of power to operate. The mobile phone charger is currently not charging, and the USB hard disk is not plugged in. The USB hub connected to the computer is plugged into a second USB tester. This will allow me to measure the power from the computer and also the power going to the mobile phone charger. I will now plug the USB tester into the computer, which is connected to the USB hub. The milliamp reading will be just below 100 milliamps, which is being used to power the USB hub. I will next put a phone on the charger to charge. Devices like phones when charging will draw a lot of power, since most people want their device to charge quickly. Since it's only drawing power for charging, it won't be detected as a device in the computer. The power will go above 500 milliamps because the phone will pull as much power as the motherboard lets it. Results may vary between different computers, devices, and chargers. Also, some USB ports designed with charging in mind will output more than a normal USB port would. These ports may be red in color. Notice that when I plug in the USB hard disk, the amount of power going to the phone drops, but the hard disk is not detected by Windows. This is because even though there is power going to the USB hard disk, it's not enough. If I had plugged in the hard disk first, the hard disk would have started up and the phone would have used any leftover power. Thus, to use some devices, it may just be a matter of plugging them in a different order. I will next plug in an external power supply into the USB hub. Notice that when I do this, the power draw from the computer goes to 0 and the hard disk is now detected by Windows. The USB charger is now picked up by Windows, but since it's only being used for power, Windows can't determine what kind of device it is, because technically it's not a device, it's just drawing power for charging. The main takeaway from this is, if you're using a USB hub and charging devices or using devices that are drawing a lot of power, make sure you're using an external power supply. If you're having power problems, consider moving devices to a different port or a different USB hub. If you're not sure, use an external power supply. Using an external power supply, even when it's not required, won't break anything. I will next have a look at what occurs when you have a USB hub that has more than 4 ports. For a USB hub to be compatible with the USB 2 standard, it needs to have a maximum of 4 ports, so each port can be provided with a minimum of 100 mA. You can get non-compliant USB hubs that have more ports, running the risk that if you unplug devices, the bus may have too much power running through it, which could result in damaging devices. In this case, the USB hub is compliant with the standard. However, it has 7 ports. To understand why, notice what occurs when I plug the USB hub into the computer. The hub is detected as 2 USB hubs daisy-chained together. This is how one can have more ports but remain compatible. If you start considering this from a power perspective, one USB hub is effectively powering the next USB hub. Thus, the computer is really powering 2 hubs and any devices that are plugged into it. You may find that you will have power problems with hubs like this very quickly. This may translate to devices not working or not being detected. You may also find that certain ports will work better than others due to them being connected to the first hub. To get around these problems, I would consider always using an external power supply for USB hubs that have more than 4 ports. Maybe you'll get good results using 7 low-power devices. But if you plug in just one high-powered device, for example charging a mobile device, this can cause power problems throughout the whole hub. Personally, I don't think it's worth the risk of not using an external power supply with these devices unless you're not planning to plug many USB devices into it. If that's the case, I don't know why you would buy such a large USB hub to start with. You may also find that certain ports on the computer may also be connected to their own USB hubs. For example, the front panel USB connectors may be connected to their own USB hub. Thus, you may find that when you connect USB devices to different ports, you may get different results. This should only really be a problem if you're using high-speed USB devices, but it is something to be mindful of when troubleshooting. This brings us to the topic of USB hierarchies. USB devices work in a hierarchy. At the top of the hierarchy is the host, which is the computer or device. The host has a root hub, which all the traffic from the USB devices will go into. Below this, you have up to 4 additional levels to make a total of 5. Going towards the root hub is upstream and going down is downstream. An upstream port can connect up to 4 nodes. Each node can be a hub or a node. Hubs that have more than 4 ports are 2 hubs connected together, and thus use up 2 tiers of the hierarchy, since 1 port is used to chain the hubs together. This is why you will see 7-port USB hubs and not 8. 1 port is lost in connecting the hubs together. Sometimes you may find that the USB ports on the front of your computer are connected to a hub before being connected to the root hub. The root hub is not limited to 4 nodes. However, sometimes the manufacturer of the motherboard will utilize a hub to connect certain ports, such as the USB ports on the front of the case. Keep this in mind because depending on what USB port you use, it may be connected to a tier in the hierarchy, rather than the root hub. Also, active USB cables that allow USB to travel over long distances may also act as a hub. This covers the basic fundamentals for USB 2. I will now have a look at USB 3. USB 3 was released in the year 2008. To better understand how it works, let's consider the problem USB had to overcome. The first thing it needed to do was increase the speed. USB 3 achieves this by increasing the speed from 480 megabits per second to 5 gigabits per second. USB 2 had gained a lot of market share, and thus, for USB 3 to be successful, it also needed to keep compatibility with existing devices. So, what was the solution to this problem? The solution was to add additional wires to the connector. These additional wires allow the same connector to transmit USB 2 and USB 3 signals at the same time. Let's have a closer look. To understand the difference between the USB 2 and USB 3 connectors, let's first consider the USB 2 connector. To remain compatible with USB 2, USB 3 needed to keep the same type of connector. In the case of the left connector, it was a simple matter of adding additional pins to the connector. You can see the USB 3 wires on the top row of wires. When I compare a USB 2 connector with a USB 3 connector, you can see the extra pins inside. In the majority of cases, the USB 3 connector will be colored blue, but if it's not, you can always look in the connector for the extra pins, which can be a bit difficult to see in some cases. Generally, in devices such as a computer, the ports will be color-coded, so you know which is USB 3 and which is USB 2. The USB 3 cable will go into the USB 3 port and also the USB 2 port. Essentially, the extra pins will make contact or they won't, but they don't affect the cable going in. The same applies for USB 2 cables. That is, USB 2 cables will go into a USB 3 port. For the Type B connector, the connector has been expanded to include the extra pins. In this case, they are at the top in the extra part that has been added to the connector. This makes it easy to identify the connector. I have 2 USB cables, a USB 2 cable on the left and a USB 3 cable on the right. Most USB 3 cables should be blue, but in the rare case that one is not, the shape of the connector will tell you if it's USB 2 or USB 3. You'll notice that the USB 3 cable goes into the USB 3 port without a problem. The USB 2 connector will also go into the port without a problem. Unlike the previous cables, since the connector is large, a USB 3 cable won't work with a USB 2 port. The next connector is the micro connector. In order to allow for extra wires, the connector was extended to contain the USB 3 wires. You can see the extra USB 3 wires on the right side of the connector. You'll notice that when I compare the connectors, the USB 3 on the right is essentially just a USB 2 micro connector with the extra USB 3 part attached. As before, the USB 3 connector will plug straight into this USB 3 hard disk. When connected, the hard disk will operate at USB 3 speeds. If I unplug the USB 3 cable and plug in a USB 2 cable, the hard disk will now operate at USB 2 speed. Something to keep in mind. If your USB device is operating slowly, it's possible that you're using a USB 2 cable rather than a USB 3 cable. This covers how the old connectors were modified to support USB 3. After the initial release of USB 3, a new connector was released called the Type-C connector. This connector does not have a USB 2 version. However, it does still have the USB 2 wires in it for backwards compatibility. Thus, the cable supports USB 3 and USB 2. As before, there are a number of pins that are dedicated to USB 3. You may notice that there are 8 pins for USB 3, whereas before 5 were added. The previous 5 consisted of 4 data wires and 1 ground wire. Thus, 4 data wires in the previous connectors and 8 data wires in the Type-C. What does this mean? Data transfer requires 2 wires to transmit in one direction. Thus, 4 wires are required for bidirectional communication. Therefore, 4 wires are effectively the equivalent of 1 data line. Doubling the wires to 8, if you have not guessed it already, adds another data channel. Thus, the Type-C connector has the equivalent of 2 data lanes. This means it's possible to transfer twice as much data using the Type-C connector compared to the other connectors. At this stage, it appears the Type-C connector is the connector of the future. Besides having an additional data lane, it can be used as a host or a device, and you don't have to worry about putting it in the right way up. Essentially, it can be plugged in right side up or upside down. These are the basic connections that work with USB 3. Now that we understand that USB 2 and USB 3 communication data travels over different wires in the same cable, let's now have a look at how the root hub handles this. In order to add USB 3 and keep support for USB 2, the root hub essentially is divided into USB 2 and USB 3 ports. These ports in the root hub are then combined together to a physical port in the computer. So essentially, the root hub acts as the equivalent of two independent USB hubs. To understand this a little bit better, I'll plug a USB 3 hub into my computer. This is a standard USB 3 4-port hub. Once plugged in, I'll have a look at USB view to see what has occurred. You'll notice that the USB hub has been detected. On the right-hand side, the reported protocols supported are USB 1.1 and USB 2. When I scroll down, notice a second USB hub has been detected. This USB hub supports USB 3 only. Thus, you can understand how USB 2 and USB 3 are both supported. Essentially, they are traveling over different wires to different ports in the root hub. If you think of USB traffic like networks, you essentially have your USB 2 network, a slow network, and your USB 3 network, a fast network. Both run independently of each other. USB 2 provides compatibility with older devices, while USB 3 does not need to worry about compatibility with older devices. Now let's have a look at how newer versions of USB are handled. The next version of USB released was version 3.1 in 2013. USB 3.1 doubles the speed of USB 3, making it 10 gigabits per second. It still uses the same connectors as USB 3. If USB 3.1 is not supported, the speed drops to USB 3 speed. Since USB 3.1 uses more bandwidth, there may be a limited number of ports on a computer that support it. Usually, USB 3.1 ports are a lighter blue than USB 3 to make it easy to tell which is which. This may not always be the case, but they should at least be labeled. In some cases, such as some USB flash drives, they may be labeled as USB 3.1. However, they can only transfer data at USB 3 speeds and not USB 3.1 speeds. When this occurs, even though the device may support USB 3.1, it's a waste putting it in a USB 3.1 port. Now let's have a look at the next version of USB. The next version released was USB 3.2 in 2017, and as before, it doubles the speed, giving us 20 gigabits per second. However, the catch to getting the extra speed is you need to use the Type-C connector. This is because the extra speed requires two data channels. The standard USB 3 connector only provides the one channel. However, you will still be able to use your old USB 3 connectors. Keep in mind that if you do so, you'll only get half the maximum speed if your device supports USB 3.2. Thus, if you use an adapter to convert a USB Type-C connector to Type-A or Type-B, you automatically reduce the maximum speed to half. Although this covers up to USB 3.2, you may experience some confusion when purchasing USB cables, devices, or determining which version your USB ports support. Over the years, a number of different naming conventions have been created for USB. It's not important to remember these names, just to be aware they exist. These have been created for marketing reasons and also as attempts to make the standards easier to understand. I don't know about you, but I think it makes everything a lot harder to understand when different devices use different naming conventions. So when you're purchasing a device, cable, or looking at a motherboard and see one of these terms and don't know which one it is referring to, look up a table like this. There are plenty of copies of this table on the internet. Often, if you look at the speed, it'll give you an indication which version of USB you're looking at. The good news is that we seem to be moving towards the newer naming standard of USB 3.2 followed by the generation. So hopefully in the future they will standardize on the one naming standard. Although this video is about USB, I will also need to have a look at Thunderbolt. For version 3 of Thunderbolt, there are two different standards, but that will change. More on that later. Thunderbolt 3 also utilizes a Type-C connector. Although the Type-C connector is often considered to be a USB connector, this is not true. The truth is that the connector can be used with any protocol. Since it uses the same connector, it also uses the same cable. But of course, there's a catch. Thunderbolt 3 can transmit data at 40 gigabits per second, which is twice that of USB 3. In order to do this, if the cable is longer than 50 centimeters or 1.5 feet, it's required to be an active cable. An active cable means that there are additional electronics in the cable to boost the signal. If you use a USB cable longer than this or a poor quality cable, it may not work with Thunderbolt. In order to ensure your cable works, look for the Thunderbolt logo on the cable. The good news is, if you purchase a Thunderbolt cable, it will also work with USB ports. Thunderbolt 3 also supports USB, so you can plug your USB devices into a Thunderbolt port. Since Thunderbolt and USB both use the same Type-C connection, in order to tell which is which, look for the logo next to the port. USB may also have a logo to identify the port is USB. If you're not sure what a Type-C port supports, have a look for logos like these. The port may also have logos on them to identify that the port can be used to power the device. For example, in the case of a laptop, the Type-C port may be used to provide power to the laptop as well as connect to USB devices. Thunderbolt did not gain a lot of market share over USB. You can see it a lot in Apple products, but not so much with PC products. At the time, using Thunderbolt required a royalty to be paid and also costed more to implement over USB. Thus, you can understand why it turned out to be not that popular, and there are not many devices on the market. The main advantages of Thunderbolt over USB are the increased speed and it's backward compatible with Thunderbolt 1 and 2. Thus, if you have Thunderbolt 1 and 2 devices, it may be worth getting Thunderbolt 3 cables even if you never purchased a Thunderbolt 3 device. However, this may change in the future with USB 4. USB 4 is not currently listed as an exam objective, but you never know if CompTIA may add it later. USB 4 was released in 2019 and so far has not gotten much market share. To understand what USB 4 is, it's easier to understand the history. To start with, Intel donated the Thunderbolt 3 specification to the USB Implementers Forum. This is the organization that effectively manages and updates USB. The USB Implement Forum made some improvements and released USB 4. One of the changes to USB 4 was removing the space between USB and the number 4. USB 4 also supports the same speed as Thunderbolt 3, that is 40 gigabits per second. Thus, in a lot of ways, USB 4 is very similar to Thunderbolt 3. It does not support all the features of Thunderbolt 3, but it is pretty close. Given that the speed is 40 gigabits per second, it requires a Type-C connection. It is the first USB specification to do away with all the other connectors and only use the Type-C connector. If I were to take a guess at what occurred, I would say that with the low adoption of Thunderbolt 3, Intel may have felt that if they gave the specification away, USB 4 would then support Thunderbolt 3 devices and thus could improve the sale of Thunderbolt 3 devices. Maybe Intel just wanted to get behind the one standard and therefore making USB 4 support Thunderbolt 3 was just their way of doing it. What this means for the consumer is that if you purchase a USB 4 computer, you'll be able to run USB and Thunderbolt 3 devices. Intel continued developing Thunderbolt and next released Thunderbolt 4. Now you can see how the technologies have merged together. There are some differences between USB 4 and Thunderbolt 4. For example, Thunderbolt 4 supports daisy chaining of devices. That is, you can plug two devices together in a chain without the use of a device like a hub. Thunderbolt also supports dual monitors, while USB 4 only supports one monitor. Through the use of devices like USB hubs, it's possible for USB to support more monitors, but Thunderbolt supports two natively. Main thing you should take away from this is that performance-wise, USB 4 and Thunderbolt 4 offers are the same. Thunderbolt 4, as before, is compatible with USB, thus you'll be able to use your USB devices with Thunderbolt. Thunderbolt 4 offers some additional features over USB 4. Most users will probably find USB 4 will meet their needs, but Thunderbolt 4 is there if they require it. That's it for all the different versions of USB. I will now have a look at USB and charging. USB originally provided only a small amount of power and was designed primarily for data transfer, and not so much for powering devices. As time went on, there was a demand for more power. Shown here is the increasing power delivery as USB development continued to evolve. I wouldn't worry about understanding too much about the information on this chart. The main takeaway is that as different versions of USB were released, the amount of current transferred through the cable has increased to a maximum of 5 amps. Originally, USB cables were not designed with this in mind, but were able to accommodate the extra current by the manufacturers, just making better quality cables. The amount of power that we can see pass through the cable is measured in watts. I will try and spare you too much of an electronics lesson, but essentially you can increase the current in the cable to a certain amount as the cable will heat up and may start melting. When you get to the limit of current, in this case 5 amps, the next option is to increase the voltage. You can see that when we get above 15 watts, the voltage must increase to increase the amount of power, or watts delivered. Type-C cables have more power wires and thus can handle more power than older USB cables. Thus, when power requirements start exceeding 15 watts, you need to use a Type-C connector. There's also another reason for this, which I will cover later in this video. So let's look at taking the information from this chart and applying it to what we need to know in the real world. This may seem overwhelming at first given the number of different cables and chargers out there. To make it simple, I've organized them from lower power on the left to higher power on the right. Your older USB 2 cables and poor quality cables won't support much power, maybe as low as 1 amp. The point to remember with devices is that they will attempt to draw the power if they need it. If they're not able to draw the power they need to operate, they may not work. In the case of devices like hard disks with insufficient power, won't spin up. With devices such as lights, they will probably be dimmed more than they should be. In the case of devices that are charging, they'll drain more power. As we saw earlier in the video, they'll draw as much power as can be handled. The point to remember is, the cable and the charger need to support the power draw required to operate the device. If the cable or charger is rated higher than what's required, that's fine, it just can't be lower. If the charger is lower than required, it won't be able to provide enough power and the device may not operate. In the case of devices such as laptops and mobile devices with batteries, underpowered chargers will generally still charge the battery. The charging will be slower than normal and is called a trickle charge. Trickle charge is when there's enough to slowly charge the battery, but not enough to power the device. Thus, if you use the device when on trickle charge, the battery will slowly drain even though you're charging it. Some laptops may display an error and fail to boot if powered by an underpowered charger. To circumvent this issue, you can unplug the power charger during the boot process and reconnect it once the laptop has started. While the charger may not supply adequate power, the gradual trickle charge can extend the battery life before it depletes completely. In certain instances, this might suffice to keep the laptop operational without charging the battery. This workaround can be useful when you urgently need to use the laptop and do not have access to the appropriate charger. If your cable is a cheap cable, drawing too much power will cause the cable to heat up and become damaged. When the cable starts getting damaged, the power draw will be reduced. This is why cheap cables will charge better when you first purchase them and will become less effective as time goes on. You may come across cables that are branded as fast charge cables. These cables are generally rated at 3 amps or more. If you have a fast charger, a fast charging cable, and a device that supports fast charging, your device will charge faster. On some computers, there may be a USB port that is designed for fast charging. These USB ports are good for devices that use a lot of power, generally devices that are charging. Since a device will only take the power that it needs, you can put a low-power device into a fast charging port. The lower-end cables and chargers will be rated in amps, but when the standard was created, no one thought about increasing the voltage. The higher-end cables will be rated in watts. In this example, we have a 30-watt charger. You generally don't find cables that are rated for 30 watts. A 5-amp cable should work fine since only the voltage is increased unless the cable is poor quality. The next cable will generally be rated for 100 watts. A 5-amp cable can handle 100 watts unless it is poor quality, it won't be able to. The 30-watt charger is essentially saying it will output a maximum of 30 watts. This is good for some mobile devices which can pull a lot of watts when they're charging. Thus, a 100-watt cable and a charger with a lower output works quite well. If you use a cable that's not rated high enough, your fast charger capacity may be wasted. When you start getting to 100 watts and 240 watts, this is well beyond what current devices on the market need for charging. You'll find this kind of power is used for devices such as laptops and external graphics cards. When you start getting to higher wattages, you need to increase the voltage. Increasing the voltage on devices that do not support higher voltage risks damaging the devices. Let's have a look at how USB handles this. There are a number of different standards of power delivery for USB. However, the only one that I will look at is the one created by the USB Implementers Forum. This standard is pretty well supported nowadays. Essentially, what occurs is the charging device is able to dynamically change the voltage and current in real time. In order to use it, the cable and the charging device need to support power delivery, otherwise known as PD. In order for PD to work, the charger and the cable must both have electronics in them that communicate with each other. Essentially, the charger asks the cable what power it can support and makes sure it does not go over this. The device attached is free to request whatever power it needs in that range. This way, the charger does not send more power to the cable than it supports. If you don't have the packaging for your charger, you can have a look at the information on the charger to help determine what it supports. The details of what it supports should be in the output section. In this case, PPS indicates it supports power delivery. PPS is a protocol used by power delivery. If you're not sure what the charger supports, you can always look up the specifications. To ensure that the charger does not break a device by putting too much voltage down the cable, it starts the voltage low and increases or decreases it as required. If your charger or cable does not support PD, this may mean when your device requests additional power, it won't receive it. Thus, the extra capacity in the charger is not used. Although there are other methods of controlling power, nowadays I personally would purchase a PD charger because it's pretty well supported. Now let's have a closer look at cables. When it comes to USB cables, the USB Implementers Forum has a certification program. On their website, you can look your product up to check if it's certified, as it says it is. There are a lot of cheap cables on the market that don't perform well. If I've not said it before, I'll say it again. When it comes to cables, you get what you pay for. When you purchase a cable, don't assume anything. Let's consider an example of two cables advertised as 100-watt Type-C cables. One assumption you could make is that it uses the Type-C connector, thus supports USB 3. This is not correct. One is USB 2 and the other is USB 3. The manufacturer probably won't advertise the cables as USB 2 because they want you to buy the cable. It may be in the specification or fine print or may be listed with a transfer rate of 480 megabits per second, hoping you don't read it or that you don't work out that it's USB 2. The USB 3 cable will probably say USB 3 because they want you to buy the cable. If the cable has good specifications, the manufacturer wants you to know about them. Most likely it will be printed in big writing on the front of the box. Poor specifications aren't put on the front of the box or are left off completely, hoping you don't notice. It's not false advertising to not tell you something, but it is false advertising to tell you something that's wrong. Thus, most manufacturers will try and make poor specifications that may result in you not buying the cable less obvious. When you purchase a cable, check things like the power supply supported, the speed it supports, or if that is not listed, at least the protocol it supports. If possible, purchase cables that are certified. Certified cables are made to a standard quality, while non-certified cables, some corners may have been cut in the manufacturing process. Although you get what you pay for, there are people out there that overcharge on cables. Generally, when possible, I purchase certified cables and try to find a cable in that range that is value for money. You get what you pay for, but don't pay more than you should. Even checking for the same cables at different stores can sometimes reveal a massive price difference. You'll be surprised how much stores will add to the price of cables, as they know some people will pay for it. Hopefully, you don't get sold a poor quality cable at a high price. Make sure you read the specifications of the cable carefully, so you know what you're getting. We've gone through a lot in this video. Let's have a look at the basics you need to know to support USB. In the real world, be able to identify USB 2 ports and USB 3 ports. Usually this is pretty easy, because in most cases the USB 2 ports will be black and the USB 3 ports will be blue. For your USB 2 port, plug in your low-speed devices. These are devices such as your mice, keyboards, headphones, and some flash drives. For your USB 3 port, plug in your high-speed devices. These are devices such as external hard disks, some flash drives, and capture cards. Your computer may also have USB 3.1 ports, which are usually a lighter shade of blue. These ports you should use for very fast devices. These are devices like high-resolution capture cards, high transfer devices, such as high-resolution cameras, and very fast storage devices. Your computer most likely does not have too many of these ports, if any at all. Your computer may have a Type-C connection. These are required by USB 3.2 in order to get maximum speed. However, this connection may be used by older type connections as well, so don't assume because it's a Type-C connection that it's automatically a USB 3.2 connection. If you use adapters, these may reduce the speed of the connection. Changing a Type-C to Type-A will remove one data lane. If you plug in a USB 2 adapter, your speed will be reduced to USB 2 since the USB 3 wires will no longer be connected. If you're using Thunderbolt, Thunderbolt supports USB devices. The main difference is that it adds some additional features not included in USB. To use Thunderbolt full features and speed, you need a Thunderbolt cable. A USB cable will work as well, but you may find that the speed will drop. If you're having USB problems, don't be afraid to unplug the device and plug it into another port. Often this will fix the problem. That concludes this video on Universal Serial Bus or USB. With USB 4 coming onto the market, USB is here to stay. I hope this video helps you support USB. Until the next video from us, I would like to thank you for watching.